So this is a continuation of projectile questions. Question 25. The photograph shows an athlete who's performing a long jump. At takeoff, the horizontal speed of the athlete is 8 meters per second. The vertical speed is 2.8%. So it means he's having a horizontal speed and the vertical speed. The horizontal speed of this athlete is 8 meters per second and the vertical speed is 2.8 meters per second. Show that the total time for an athlete spent in air is about 6 seconds. To solve such question, what we always do, we find how much time it will take to reach the maximum height and the total time will be twice of it. So the vertical component will be 0. It's on Earth, the expression will be due or deceleration due to gravity 9.81 meter per second square. So we'll use the formula S is equals to ut plus half at square. Initial or we will denote the distance, so we can find using the equation of the motion v is equals to u plus t. The final vertical is 0. The initial vertical is 2.8, as they already mentioned the question. And acceleration is due to gravity, which is 9.81. So this will be 2.8. But because it will decelerate, so we'll write minus 9.81. When we simplify, this will be actually like minus 9.81 move other side, so plus 9.81 t and then divide. So t is equals to 2.8 divided by 9. When we divide them, this will give us about 0.285 seconds. That's a time it will take to reach the maximum height. And the total time, like the remaining 0.285, if it land on the same position, then the time will be same. Otherwise, if it land a bit higher or lower, then the time will not be same. So we assume that it lands on the same position, same level, so the time will be same. So the total time of the flight will be double of. So when we multiply 0.285 multiplied by 2, that's equal to 0.57 seconds. So 0.5 seconds, 0.57 second, this athlete will take to land on the same level. Calculate the horizontal distance. So as we already worked out the total time, so we need the range. We need the horizontal distance. So we have the horizontal speed. We need the distance here. So distance is speed multiplied by time. The horizontal speed is 8 and the total time of the flight is 0.57. 0.57. So when we multiply, this will give us the distance, or we also call that distance, horizontal distance, as range. So this is about 4.6 meters. Similar patterns are there in the solving question, like first we get the total time of the flight and finding the time to reach the maximum height and then finding the range. In reality, when the athlete lands, his center of the gravity is 50 centimeters lower than the position of where it calculate the extra horizontal distance. This enables the athlete to jump. So how we can work out the extra horizontal distance? So basically what happened if we ignore the air resistance as we are solving such question, we ignore the air resistance. The horizontal speed was 8 and the vertical speed was 2.8. When it is at the athlete is at its maximum height, he's having only the horizontal speed, which is 8, but there's no vertical speed. But if he lands on the same position, like if he lands on the same position, then he will also have the same vertical and the horizontal speed, but the direction will be opposite. So this is 2 point, sorry, horizontal was 8. So this is 8. This one is 2.8. This one is 8 meter per second, and this one is 2.8, or you can also say negative 2.8 because it's in opposite direction. So first, what we will do, now we'll consider a motion from this point. Like example, if extra 50 centimeter, he falls like extra, say this was a trajectory, the path of an athlete. If he lands on the same level, but what happened, he lands 50 centimeter below, which is about 0.5 meter. So this is the complete path of a projectile, and this is the extra 50 centimeter, or we can say, because the distance should be meter. So 0.5 meter below the original level he falls. So that's equal to 0.5 meter. Now what we will do, we will first find how much time it will take to fall this 0.5 meter. And after finding the time it will take to fall this 0.5 meters, we will work out the extra distance he covered, like this range we can find, if as we already know the horizontal component, because see, the horizontal component is 8 and the vertical component is 2.8 meter per second. At this point, the horizontal component is 8 and the vertical component is 2.8 as well. So first, with the vertical component of a velocity 2.8, and we'll find how much time it should take to cover this. So we'll simply find how much time it will take to cover this 0.5 meter. And so first we'll find the final, like this is 2.8, but we'll find what is the vertical component at this point, because the vertical component won't be same. The vertical component will change. So first we'll find what will the vertical component if the initial component is this, and then using the initial and the final vertical component, we can work out the time. So we have this equation of the motion that v square is equals to 2as plus u square. So 2, and it is falling, so it will be 9.8, not minus, and the vertical distance is 0.5 plus u square. What is u? U is 2.8 square. So for first we are finding this v. After solving, we take a root, so we get the v. V will be 4.2 meter per second. Now we have basically like one of the velocity, the vertical velocity is 2.4 when he is falling, 2.8. One of the velocity is 2.8, then the next velocity is 4.2. So 2.8 meter per second. This is 4.2 meter per second. So we will find how much time it will take, because, and the vertical distance which is fallen, this vertical distance, the vertical distance which is fallen is 0.5 meter. So this distance is 0.5 meter. And the acceleration will be due to gravity, which is 9.8. So we have the initial vertical, we have the final vertical, we have acceleration, so we can find time. So V is equals to U plus AT, Or if I need time, it is v minus u divided by a is equals to t, where v is the final speed, 4.2, u is the initial speed, 2.8, and acceleration is due to gravity, 9.8. This will give us how much time it will take to fall to this 0.5 meter or 50 centimeter. Now we have the time and we have the horizontal speed, so we'll find the horizontal range here, like extra distance. So range is speed multiplied by time. So that will be equal to speed into time. The speed is equals to 8. This is speed. So speed is equals to 8 multiplied by time. That is 0.1. So we multiply. This will give us about 1.1 meter. So like it will be 1.1 meter extra distance athlete will cover if athlete landed not on the same level, but a lower level from the point where he, because center of mass is here, and then when he land, his center of the mass is 50 centimeter below the point from where he jumped. So that's why he will cover an extra distance. Is it a clear discussion? The next part, like this was the last part, 25. I was done. 26. A rocket is launched at the level of one end of a long table and land on the other end of the same level. The student measure the horizontal distance, the time for flight, so that the horizontal component is, so basically a rocket is launched and it lands on the same level. The range of this rocket, the maximum distance, that is 1.88, and the total time, how long it will remain here, like will rise up and come down. So it will rise and come down. The total time of the flight is equals to 0.88 seconds. We need the horizontal component of the velocity, first part, and then we need the vertical component. First one is horizontal. The horizontal component, that's a speed equals to distance. The horizontal distance is 1.88, and the time for this rocket is 0.88. So 1.88 divided by 0.88, that will give us the horizontal speed of the rocket, which is 2.14 meter per second. The next, show that the vertical component of the initial velocity of a rocket is about 4. Now, the vertical component. So, to get the vertical component, what we'll do, we will take half of its motion. Like it was taking 0.88 seconds. The rocket is launched, then it's coming down with the same horizontal and vertical. Horizontal we already worked out. So we'll take half of the motion. When we take half of the motion, this this is the like initial velocity, but it will have two component, vertical and horizontal. Horizontal we already calculated. Initial we want vertical, we want to calculate what is the final vertical, that will be 0 at the maximum height. If the total time of the flight was 0.88 seconds, then half will be 0.44 seconds. And acceleration will be, deceleration will be due to gravity now, minus 9.81. So we use this equation, v is equals to u plus at. The final is 0. Initial we are finding 9.81. And time is why I did not take the full time, because the total time of the flight was 0.88 seconds. So half will be 0.44 seconds. And this is minus, so because it's decelerating, so this will be negative. This minus this other side, 9.81 into 0.44. That will be the vertical component of the velocity, which is 4.3 meter per second. 4.3 meter per second is vertical. So we calculated the vertical component, that is 4.3, and we calculated the horizontal component, was 2.1 meters. That's in the previous part we calculated. Then calculate the initial velocity of the rocket. Now you have the horizontal and vertical components, so you can use Pythagoras theorem to work out the initial, because like we need the initial velocity. So I need this velocity. I need this, and I have horizontal and vertical components. So if I use a right angle triangle, I have the base, I have the perpendicular, so I need the hypotenuse. So this is what we need: 2.14 and 4.3 meter per second. So if we need this, we use the Pythagoras theorem. The hypotenuse square equals base square plus perpendicular square. And then if we need x, that is under root 2.14 plus 4.3 square. That will give us the value for the initial velocity. And we can also find the angle if we need this angle, the direction, if they ask theta. So theta is equal to tan inverse, because we have the base, we have perpendicular, so tangent theta is perpendicular divided by base. So if I need the perpendicular is 4.3, the base is 2.14, equals tangent theta. So theta equals tan inverse 4.3 divided by 2.4. So when we simplify, this will give us the angle, which is 63.9 degrees. The value of the x is 4.8 meter per second. So we have the horizontal distance, the initial velocity from its component. So if we have horizontal and vertical components, we can just use the Pythagoras theorem to work out the initial and the initial velocity. And same thing, if we know the vertical component and horizontal component for final velocity, we can also work out the final velocity, the total velocity. The students obtained their data by filming the flight. When they checked, the maximum height reached by the rocket was found to be less, suggest why the maximum height reached is less than the predicted. So what might be the possible reasons? The reasons, because technically there is a air resistance. We don't consider air resistance, like we assume air resistance is negligible, but there air resistance is there. So uh, like air resistance opposes the motion of the rocket as it is going up. So the time it will, or energy will be lost or dissipated. That's why it will take, like it will come, not reach the height which we calculate, or it will be lower than. Give advantages of filming the flight to obtain the data. Like what are the advantages of using a video camera rather than using a stopwatch? So the first thing, it's difficult for a human eye to catch or observe this motion. Like reaction time will not be involved, as we're not using the stopwatch. We can zoom in to check the height. We can slow down. We can watch frame by frame. These, like we can watch again. That is one advantage. It reduce, like there's no reaction time involved. We can slow down the motion with reference to the frames. So these are the advantages of using a video camera over the stopwatch if you time with the stop. So still question 30 and 31 are left, but that I will record and share with you.